In this video, we are going to learn about recursion. Recursion is nothing but a strategy that algorithms use to solve certain problems. So what is this strategy? A recursive algorithm is an algorithm which solves a main problem by using the solution of a simpler subproblem of the same type. So let me repeat that. What does it do? It solves a main problem by using the solution of a simpler subproblem of the same type. Let me explain this with a quick example. Let us say I want to calculate 5 factorial. So I'm going to call the function factorial of 5. Now, you and I know that 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. Now, this 5 factorial could also be written as 5 into 4 factorial. Now, it is easy to ascertain that for any n factorial will be n into n minus 1 factorial. So, when I say I want to calculate the factorial of 5, if I were to break it down into a simpler subproblem and use that solution, I would say that factorial of 5 is equal to 5 into factorial of 4. I'm sure you agree because it's the same as this step. So I say that I'm going to call the function factorial and ask it to find the factorial of 5. What the function will do is, the function will say, okay, I will calculate factorial of 5, but I need factorial of 4 because factorial of 5 is equal to 5 into factorial of 4. At this point, the function will make a call to itself. So, we have called factorial of 5. Now we are inside the function. The function says factorial of 5 is equal to 5 into factorial of 4. So, within the function itself, we are calling the same function. So, what is another important point of recursion? The function calls itself. So now, when we say we need to find factorial of 4, the function will run again, this time for 4, and it will say factorial of 4, as you might have guessed by now, is 4 into factorial of 3. Once again, within the function itself, the function is going to call itself. Now, the function for factorial of 3 is going to run. Factorial of 3 is equal to 3 into factorial of 2. So we have to keep doing this. But when do we stop? Right? If we keep going n into n minus 1, so where is the stop point? When do I actually get a conclusive answer? So when we keep reducing the problem size, as you can see, the problem size of the function goes on reducing. There's 5, then 4, then 3. Now we'll have factorial of 2, which is equal to 2 into factorial of 1. Then we have to have factorial of 1. So the problem size given to the function will keep on reducing. At a point, the problem will become so simple that we don't need computations to solve it, and we can give a direct answer. For example, factorial of 1, I know that factorial of 1 is 1. Or rather, let's say we go one step further. We say factorial of 1 is equal to 1 into factorial of 0. So now we have reduced it until the point where we have to find factorial of 0. Now we know that factorial of 0 is equal to 1. That's a rule in maths. So factorial of 0, we know for a fact that factorial of 0 is equal to 1. There is no dispute about this, and there is no computation regarding this either. So we have reduced the problem to such a state where it has become so simple that we have a defined answer and there is no computation for that particular case. So now we have gone on reducing the problem size, we have reached 0, and we have a conclusive answer for this simple function. So now that I know that factorial of 0 is 1, I can substitute this in the previous function call. So in this function call, I will say that 1 into factorial of 0, and I know that factorial of 0 is 1. So factorial of 1 is 1 into 1. So this is equal to 1. So what have I got from this step? I know that factorial of 1 is equal to 1. Using this information, I can arrive at the result of factorial 2. So 2 into factorial of 1. I've just now found out that factorial of 1 is 1. So 2 into 1 is 2. Similarly, 3 into factorial of 2, which is 2, which will give me 6. 4 into factorial of 3, which is equal to 6. So 4 into 6 is equal to 24. And finally, 5 into factorial of 4, or 5 into 24, is equal to 120. In this way, you can see that we are solving a main problem by using the solution of simpler sub-problems. At each time, we are finding the solution of the problem by using the solution of the sub-problem. The only time we don't do this is when the problem has become so simple that we can give an answer directly. So this is a basic gist of what recursion is going to do. Later, we will look at how we are going to program this. So, as a recap, recursion is a strategy that algorithms use in which a function will call itself. This is done so that a main problem can be solved by using the solution of simpler sub-problems of the same type. This can be done until the problem becomes so simple that a declarative answer can be provided. Once a definite answer is provided, through step-by-step substitution, the main problem can be solved. This is how recursion works.